Hi guys, I'm so sorry I couldn't be there today, but my daughter broke her foot, so I'm home being a mommy. So we're going to take notes over this today by me telling you by this podcast. So on your little notebook, I want you to write 1.4/1.6 absolute values and inequalities. If at any point I'm going too fast, just tell us to pause the video so you can get everything written down. Okay? So that's your title and what we're doing. The first example we're going to do is you're going to simplify expressions given absolute values. So we're going to start with absolute values first. Okay, as you're writing all of this down, I'm going to tell you some stuff. Absolute value is the distance from 0. So if you're trying to find the absolute value of -5, it would turn out to be a +5. And absolute values are these little lines right here. So no matter what's inside here, whatever the number is at the end after you simplify, it's always going to come out to be positive. So if this produces a -30, the absolute value of -30 would be a +30. So we're going to do a few examples. So if you don't have this written, tell the sub to slow it down or pause it, okay? So you're going to plug in 4 for B, -3 for A, 6 for C, and -3 for A. That's going to give you this. Okay, so you're going to plug them all in, you're going to put them in parentheses, and when you're working with absolute values, you want to use order of operations. So we're doing PEMDAS today. So parentheses is what you start with first. You treat the absolute values like a parenthesis. So we're going to deal with the inside first and leave the outside by itself. So if you use your calculator to do this, or if you do it by hand, 5 times -3 times 6 is a -90. And the -2 times -6 is a +6. Then you add those two together and you would get -84. Now we're going to deal with the absolute value. So since this is the distance from 0, the absolute value of -84 is going to give you a +84. So I'm going to have 4 minus 84. And then you can actually subtract them and do 4 minus 84, which means your answer is actually 80. Okay, so that's the first one. The next one is going to be something similar. So the A, B, and C are all the same. We're just doing a different expression. So go to example 2 and write that down. So this says -2 times the absolute value of B minus 5C. So because there's nothing in between the -2 and the absolute value, that means there's a multiplication sign there. So you're going to plug in all the values, get here. Then you're going to simplify inside the absolute value first. So 4 minus 5 times 6. Order of operations says to multiply the 5 times the 6 first, then subtract. So you have 4 minus 30, which is going to give you a -26. Then the absolute value of a -26 is a +26. And you would multiply the -2 times the 26 to get -52. This is being multiplied because there's nothing there. So your answer is -52. Okay, like I said, if I'm going too fast, tell the sub to pause it because I am trying to do this quickly. So solve for x. So this is actually an absolute value equation, meaning that there's two values you can always plug in for x that will create two answers for this. So there is generally a positive number that you could plug in, and there's generally a negative number that you could plug in that would produce a +13 when you plug that number in for x. So if you're always going to have two answers, here's what I do. And that's if you have an equal sign, you're going to have two answers. I always draw two little arrows because I know I'm going to have two answers. The first equation, I'm going to take what's inside the absolute value, -2x plus 9, and set equal to +13. Because whatever comes out here could equal a +13, or it could equal a -13. Because the absolute value of -13 is a +13. That's why. So the left-hand side of the equation is exactly the same, but the right-hand side, you take the number at the right and make it positive and negative. You're going to solve those independently. So this one, you're going to subtract 9 from both sides, and then you're going to divide by a -2, and you're going to get -2. On the right-hand side, you're going to subtract 9 from both sides, then divide by -2, and get x equals 11. They both are your answers. You can go back and check your work if you'd like to by putting -2 in for x. -2 times -2 is 4, plus 9 is +13. The absolute value of +13 is 13. Over here, if you put 11 in for x, -2 times 11 is -22, plus 9 is negative 13. The absolute value of negative 13 is a positive 13. So both of them work just fine. Okay, so for example 4, when you write this one down, I do not like when books put the negative 17 on the left-hand side. So when I write this down, I would put it on the right-hand side. So I'd write the absolute value of 2x plus 3 equals the negative 17. But before we start this problem, we're going to talk about the rules of absolute values. Absolute values always produce a positive number inside the absolute values. So is there any way you could ever plug any number in for x that would give you a negative 17x? Or negative 17? No, there's no way you could get that. Nothing. Even if you had negative 17 inside the absolute values, when you applied the absolute values, you'd have a positive 17. So this is a no solution. Okay, we're going to do one last absolute value one, then we're going to start some inequalities. So for this absolute value, you have things before the absolute value, you have things after the absolute value. You can only split an absolute value if you have nothing behind or in front of the absolute value. So we're going to move the 3 over, we're going to move the negative 1 over, then we can split it, drawing those arrows, and finding both of the answers. Because you will have two answers because it's an absolute value. So the first thing you're going to do is you're going to move the minus 1. So you're going to add 1 to both sides. Then the 3 is attached to the absolute value by multiplication. So you're going to divide each side by 3. And you have the absolute value of 5x plus 1 equals a positive 2. Then you're going to split it. Whoa, sorry. Then you're going to split it. You have 5x plus 1 equals a positive 2. 5x plus 1 equals a negative 2. We're going to solve those separately. So this one on the left, you're going to subtract 1 from both sides. Then divide by 5, and you're going to get 1/5. You want to simplify that fraction if possible, but that one is always simplified. So on the right, you're going to subtract 1 from both sides, divide by 5, and you're going to get x equals negative 3/5. Those are your two answers. So again, on this one, you have to move the 1 over, you have to move the 3 over, because you cannot have anything in front or behind the absolute value before you split it. And when I say split it, I'm talking about these little arrows where you have the left-hand side is the same on both of them, but the right-hand side is one positive and one negative to get your two answers. Also, if you end up with a 0 right here, you still technically do have two answers, but you're going to have the same answer twice, so you just have to solve it once, which is going to happen on your homework assignment. So don't let that stress you out. So those are all your absolute values. Now let's get into inequalities. Before we do inequalities, here's just one inequality reminder. You may want to write this down, you may not need to write it down, it's up to you. But when you have a greater than or a less than symbol, they are going to create open dots when you graph them. If you have a greater than or equal to or less than or equal to, those are going to create closed dots when you graph them. We're going to review that in a second and see a real problem. Okay? But you may choose to write that down. I would if it were me, I'd write these two things down, but I can't force you to write things down. Okay, so these are inequalities we're going to solve and graph them. We're going to start with a really easy one, then we're going to do some tougher ones. So this is just one inequality. Think of this like it's an equal sign and how you would solve that. So this is an equal sign. I would add 5 to both sides, and I'd have negative 4x is less than 8. Then we would divide each side by negative 2. Oh, whoa. You divide each side by negative 4, which would create a negative 2. But hopefully some of you are thinking, oh my gosh, red flag, red flag, red flag. Whenever you divide by a negative, you have to flip the inequality. So this less than is going to become a greater than symbol. So that only happens when you multiply or divide by a negative inequality. Or divide by a negative number. Sorry. Whenever you divide by a negative number, it will flip it. So right here I wrote, when you divide or multiply by a negative, flip the inequality. Okay, you may want to write that down. So that's solving. This is your answer, but now you're going to graph. So you're going to draw a number line. And it doesn't have to be perfect. Draw a straight line. Put negative 2 smack dab in the middle. And then I generally like to put another number on there. You could put on the left or the right, as long as the number on the left is smaller and the number on the right would be bigger. So once you've drawn that, this is going to be an open dot because it doesn't have a line underneath it. So you're going to draw an open dot. I'm going to attempt to draw one too. And then we're going to figure out what side to shade. Really, you should do a test point. You shouldn't go, oh, well, it's a greater than symbol, so it's going to be greater than. Because if this inequality was flipped around, then it would look a little different and it would be confusing if you followed that trick. So what I like to do is test points. So I'm going to decide if -3 makes this inequality true. So I'm going to think to myself, if I put -3 in for x right here, is -3 greater than -2? And that is false. So I would not shade the 3. If I plugged in a test point over here, like -1, is -1 greater than -2? And I would say yes. And then I would shade to the right. You can use a highlighter, you can use a pen, you can shade pretty much however you'd like. A lot of times I use this type of shading. Ooh, I'm doing little circles, it's not going well. Or you could do this where you shade like that. As long as you're shading, I'm not going to be too picky. Okay, so that's if you have one inequality. So sometimes they'll give you what are called, oh, don't look at the answer. They give you compound inequalities. So this is two inequalities together. So we're going to solve this one. Now I'm going to go pretty quick through this because I don't want my video to be super long. So just pause it. So when you're solving this, you want to get x by itself. But you have two inequalities that are just shoved together. So you're going to work on from the inside and work your way out. So I need to move the 8 first. And I'm going to subtract the 8 over here. But then I'm also going to subtract 8 over here. So because I have two inequalities, I have to subtract from everywhere. So subtract 8 here, subtract 8 here, subtract 8 here. That's going to give me -22 is less than or equal to 4x, which is less than or equal to 24. Then I stick in the middle. I'm still trying to get x by itself. I'm going to divide all of them by 4. All of these get divided by 4. That's going to make a 6 on the right. On the left-hand side, -22 divided by 4 would reduce to -11 over 2. So this is my answer, but now I'm going to graph. So I'm going to make a number line. The smaller number is going to go on the left, so the -11 over 2 is on the left. The bigger number is on the right, which is 6. And then I just put a number in the middle, 0, so I can do some test points. So right here, this number right here, or this inequality right here is going to be a closed dot, so you're going to draw a closed dot. Make sure it looks closed. Oh, that looks terrible. Okay, and then on the right, you're going to draw a closed dot as well. And you could plug in the test point to see what to do. I could plug 0 in right here, and we're going to see if it's true. Is -11 over 2, which is the same thing as -11.5, less than or equal to 0? And that is true. So I would shade towards the 0 from the -11.2. Now I'm going to see if I'm going to shade towards the yellow or if I'm going to shade away from the yellow for the other part. 0 is less than or equal to 6. Yes, that's true. So I'm going to shade towards each other. Most of the time, I don't know if it's 100% sure true, but I'm going to say 99.9% of the time, if you have an answer like this, where it's all shoved together, which is called an AND problem, you're going to shade towards each other. I'm going to show you an OR problem in the next slide. Okay. Oh, I did it again. We're going to do an OR problem, which you will see OR problems have two equations with an OR written in between them. So instead of shading towards each other, they're going to shade away from each other. So we're going to see what that looks like in a sec. So for the one on the left, you're just going to add 6 to both sides, and you're going to get g minus 5. G is greater than -5. That's the left-hand side. On the right-hand side, I'm going to subtract my 4. Then I'm going to divide by my 2. And I'm going to get -19 over 2. When I graph these two, you want to put the smaller number on the left. Well, -19 over 2 is the same thing as -9.5. So that's going to go on the left because that's smaller. So I'm a number line that looks like this. So let's see. Both dots are open. And then you should probably check but ore problems are going to